Okay, so we'll start from that comparison test. So what we did last day, that first of all studied some sequences and some sequence properties and the definition of infinite series. Then our aim is here to test whether a given infinite series is a convergent series or not, and for that we use some tests that we have done last day, and also to particular series we have studied, like one was geometric series, and one was geometric series, this one, and another is that p series,
Please.
and using and the condition for convergency of the active series that we have studied. Uh, Now, with the help of these two series, we can study the or test the convergency of some other given series, and we have to study some test. First was comparison test that we have discussed last day. So once again, I am just line out that convergency test. So what was the comparison test? That we have two part, one not two part, you can express in two different way. One is direct comparison test, another is the limit form. Two forms are there. One is direct comparison test, another is limit form. In direct comparison test, an and bn, that were two series, whenever this an and bn, out of these two series, one will be known to you, some known series, and you have to test the other series, other bn series or an series, the convergency of that series. So suppose if an less than equal to bn, if this condition has, we have an less than equal to bn, and if we have the bigger one, you remember like this, the bigger one, this bn, if bigger one is convergent, then the smaller one is also convergent. If the smaller one is divergent, then bigger one is divergent. That is given here. That if the Bn is convergent, then An is also convergent. If An is divergent, then Bn is divergent. And hello, all of you, please mute your microphone. And another form is that comparison test. Sorry, limit form. In this form, we have two series an and bn, and mostly and these two series must be a positive term. And if we take the limit n tends to infinity, an by bn is equal to l, where this an by bn is equal to l, where this l is finite and greater than 0. First we consider this l is finite and greater than 0, then both this an and bn either convergent or divergent. That means both are convergent or both are divergent when L is finite greater than 0. Okay, this is hold for L is equal to 0 and infinity also, but we have some restriction. For L is equal to 0, only both are converges, and L is equal to infinity, only both are diverges. That means if somewhere you are getting, please mute your microphone, all of you. Someone is unmute. Please mute your microphone. All of you check. Hello, someone is having your microphone unmute.
So you mute us, that will be okay.
Really, I don't want to do this because you cannot raise your hand in that case.
Sir, it's muted. Sir, the person is muted now.
Okay,
Can
okay,
continue.
fine. Okay. Now, you see, suppose somehow we are getting L is equal to 0 or infinity. In that case, you have to be very cautious. What? That for L is equal to 0, you cannot say anything about divergency. You can say only convergency. Suppose L is equal to 0, you are getting, and the known series is convergent. then you can say about the unknown series that is also convergent. But for n is equal to infinity, the reverse one. Okay, so we'll do this by an example. Suppose we have now one example. One series is given like this. Determine whether this series is convergent or divergent. Okay, so what we do, this is you have to test this series. You have to test. We will take either the help of P series or the geometric series. Keep in your mind. So suppose this is your an. So I am writing an is equal to the given series 2 to the power n plus n. This is your an. So you need to choose some Bn which may be some P series, maybe some geometric series in such a way that we will having, if you use direct convergency, if you will having an less than equal to Bn, or maybe Bn an greater equal to Bn, whatever. You have to choose like this, and you have to test for the convergence. So how we'll do it? So this is
Sir, we cannot see the problem.
hmm?
Sir, we cannot see the problem and whatever you are writing on the board.
All of
I mean,
you
the
are
page
not
has
seeing
not changed from
all
the limit comparison.
all of your need.
No, sir, we can see you.
No, sir,
We
we
can
can't
see
see.
you.
No,
I
sir,
can.
we can
So
see
you
you.
check
Yeah, I can
your
see.
connection. Okay, so particular
I
problem,
can
that
your
means you have.
see, sir.
Okay, okay,
We
okay.
can only
Fine,
see.
fine, fine. You check your network connection, I think. So n is equal to, suppose this one, 1 by 2 to the power n plus n. So now see, n is what? N is from 1 to infinity. So can I write this 2 to the power n plus n? This is always greater equal to 2 to the power n for all n. Then can I write 1 by 2 to the power n plus n? This must be less than equal to 1 by 2 to the power n.
Yes, sir.
So this is your an given series. Now choose this is your bn. So we are having an less than equal to bn. So we are having here an less than equal to bn. This one. So when an less than equal to bn, if you know that the bigger one is convergent, then you can comment on this smaller one. Now see, this bigger one is what type of series? Summation 1 by 2 to the power n.
P series.
PP.
P series or geometric series?
Yes, sir.
GP.
Geometric series.
Geometric series.
Geometric series,
Geometric.
and you
GP.
have x is
Geometric
equal to.
We are
series.
not able to access problem.
So in that case, x is equal to what? 1 by 2, and you know for x less than 1, the series is convergent. So you know this series is convergent. You can comment that this series is convergent. So this one also convergent. You can say this series is a
So
convergent
we
series.
don't have to calculate the limit an by bn.
No, here you can use either direct convergence test or the limit one. Sometimes your limit convergence will be sorry. Sometimes the limit test will be helpful to you. Sometimes maybe the direct convergence. Here you see, here, suppose if you want to choose here the limit series. In that case, you arbitrarily if you choose bn is equal to 1 by 2 to the power n. You see, okay, listen to me. The problem is complete here. No need to do further anything. You just write this series is convergent. Now I am writing, suppose if you want to apply here the limit series. In that case, you have to arbitrarily choose trial and error method, B1, Bn. There is no hard and fast closed rule for this chosen Bn. Sometimes we have some tricks, but not always. So if you choose Bn is equal to this, now what will be your an by Bn? This limit n tends to infinity. What you actually want to find, that we must have some finite number. First choice is finite number. If you have some finite number, you can easily say both are convergent, both are divergent. So limit n tends to infinity. Can you find this limit quickly? 1 by this is what will happen, an by bn. So bn will be, this will be 2 to the power n by 2 to the power n plus n. That is limit n tends to infinity. You can write 1 by 1 plus n by 2 to the power n. So what about this limit? You can apply if you know that L'Hospital rule, because 0 by 0 form is there. So infinity by infinity form is there. So you can apply L'Hospital rule. Do you know L'Hospital rule?
Yes, sir.
Yes,
So
sir.
if you apply L'Hospital rule, what you will get?
Yes, sir.
What you will get?
Yes, sir.
Okay, okay, fine. What you will get? Simply differentiation of n with respect to n. So
So
1 by
1 by
1 by 2 to the power n ln 2.
1
1
by 2
by
to the
2
power
to the
into
power n
ln
minus
1 by 2
ln
to
2.
1
the
by 1
power n
हो
ln
जाएगा.
2.
So this limit will be what? Tending to 0? Yes or no? So let's limit tend to 0. That means this is equal to 1. So we are getting a
Sir.
finite limit. We are getting a finite limit other than 0 and infinity. So you can say both are convergent or both are divergent. So you can say A and Bn both are convergent or both are divergent. And you know by using geometric series that Bn is convergent. So you must have An is also convergent. Okay.
Okay, sir.
Next, you take another example like this. So determine whether this series is convergent or divergent. Similarly, here also consider An is equal to n cube
Sir,
minus, yes.
sir,
Yes.
if we do that limit test, then we must do that previous test also, no, sir?
No,
Like,
no need to do.
if we
Only
are,
one test, either direct test or limit test. Either
but
direct
if we
comparison
do
test
limit
or
test, then
limit.
we may get like we may get that diverge also, no, sir?
Huh?
Either it is convergent or divergent, no,
Huh?
sir, if we do
Either it
limit.
is convergent or divergent in limit form. So, and you know that Bn series is a geometric series which is convergent. That is confirmed. No.
Okay, okay.
So there we can say An also convergent. Now, if An is equal to this, you see, for this type of problem, you can use directly the limit test. Because for this type of series, I can show you one trick to choose the Bn. So how will choose Bn? You see, An is equal to n cube minus simply if like this power of n. In that case, what you will do, Bn you choose like from An, what is the numerator highest degree that you write? That is n cube.
1 n cube.
Highest degree. Numerator also highest degree you write. N to the power 4. This is a trick, not always hold. So Bn is equal to, you can say 1 by n. So choose Bn is equal to
Sir,
1 by
but
n.
this Bn is diverging, na?
So no problem. I will check first that whether you are getting some finite limit or not. If you are getting finite limit, you can say. If you are not getting finite limit, in that case you have to be cautious. I have told you, na. If you are getting finite limit other than 0, you can say both are convergent, both are divergent. So it may be divergent. Okay, let's check. So Bn is equal to what? It is a P series, and you know that this is divergent. This will be divergent. You know that. So now, what you need to find? Limit n tends to infinity, n by Bn. That will be what? Limit n tends to infinity, n by Bn will be what? Just write down. This will be n cube multiplied. So n to the power 4 minus 2n square. I may have mistake. And denominator will be n to the power 4 plus 3. So
The
this
2n square, n4,
Sir,
n
1.
2n
raised to
square.
n
Okay, okay,
square.
okay. 2n
Yes,
1.
sir.
square. So the limit will be 1. Yes, sir. You check calculate this limit. Limit will be equal to 1. So
Yes, sir.
which is finite,
Yes, sir.
other than 0. So don't have to cause us anything. So you will have both are convergent. Both are divergent. Why? Because 1 by n is divergent, you know. Both are divergent. So an also divergent. So an is a divergency. So an will be a divergence.
So 1 by n is divergent or
Hmm.
convergent?
By n is
P
divergent.
series.
P
No,
series
divergent.
1 by n
Divergent by
Summation
P
If
series.
p equals to 1, it diverges
So
always.
1 by n convergent.
p
P.
greater than 1 convergency and p less than equal to 1 it is divergent. So it is divergent series. So it is divergent. Now,
So we can take a Bn as divergent series also, na? Means
Bn is
uh,
divergent.
it is not mandatory that we should take Bn as a convergent series
Yes,
only.
yes, that I. So what you would like to choose Bn? Tell me. Suppose you are choosing. Okay, I'm coming to your point. Suppose you are choosing Bn is equal to 1 by n square. It is a convergent series. That is your point, na? I can choose.
Yes.
We are saying that I can choose Bn is equal to 1 by n square also, where in 1 by n square is a convergent series. That is your point. Yes or no?
Yes, sir.
So in that case, what will be the limit? Tell me quickly. Limit n tends to infinity. An by Bn will be what? Quickly find out. N by Bn will be n to the power 5. This one will be n to the power 5 minus
Infinity.
So you are getting infinity.
Yes,
Limit
sir,
you are getting
infinity.
infinity. Yes or no?
Yes, sir.
Limit
Yes,
infinity. In that case, you have to be cautious. What was the comparison test? That if L is coming infinity, in that case, only for the divergence it will hold, not for the convergency. And you see Bn is convergent series, so it will not hold. So test fail here.
Okay, sir.
Comparison test will fail here. So whatever you are choosing, that will be a perfect choosing. Okay, that's why I'm telling you. Suppose for the if you are getting 0, so always your aim will be first to choose Bn in such a way that your limit n tends to infinity an by Bn will be equal to some finite value other than 0. That will be first step. If you are not coming with this finite number with some 0, a non-zero value, so in that case you may go for 0 and infinity, but in that case you have to choose if you're finding 0, in that case Bn must be a convergent series, and if you're finding infinity, in that case n must be a divergent series. Bn must be a divergent series. Okay, so this is comparison test. I have given some problem here. I'm given some problem here. You can practice with this. If you have any problem, in that case we can discuss later. So I'm giving some problem to you. I think it will be, you can just follow my comments, you will do able to do it. So let me
And
go to
sir,
the bolo.
sir, in the previous question, sir, you can so the n is starting from 2, then still that 1 by n will be divergent. I mean, so it is starting 1 by 2, then 1 by 3, 1 by 4, and dot dot dot. So ultimately, it will
Last day
turn to
I have
conjugate.
discussed lot about this. Last day we have discussed lot about this. What was that? It is not that whatever you are seeing, that is not the correct thing. Whatever you are seeing, you see actually if you go through the P series proof, if you go through the P series proof 1 by n to the power p, in that case you can see that this will be greater equal to some 1 by 2 to the power n series. We can comment like this. I can do one this thing. If everyone having confusion with this, I have to prove this in P series. Okay, so you have to arrange some different class at evening or whatever your preferable time. At that class I will discuss the proof. Actually I'm not I not like to do this proof in regular class, because it will take one class. That's I told you last day. Okay, there you can see. I will send you the one copy. There you can see with them. Okay, so all of you are here.
Okay, sir.
So
Sir,
bolo.
hello.
Yes, sir. Yes, sir.
Sir, can you give us some basic series which are convergent and divergent? Some 5 to 10 series.
I'm not getting what you are saying.
Some basic series to compare these questions with. Can you tell us some basic series?
Yes, sir. If we can have some series already, list of series which are convergent or divergent, we can easily use them to compare.
Oh, I have given some problem to you, na? This problem set is a basic.
Yes, sir. We need some comparison series,
Yes,
right?
sir.
Like
For
you told us,
example, 1 by
1
n
by 2
is
power n is a
divergent. We
convergent
know.
series.
So if there are other series like 1 by n, which we already know that they're divergent or convergent. If we know
Okay,
their nature, it will be easy
that two
for us to
series is
compare.
enough. That P series and geometric series is enough. Always,
Okay, sir.
Yes, sir.
always you will be having. You have to compare with either P series or geometric series.
Okay, sir.
Any series you have to compare with either P series or geometric series.
Sir, I have a doubt, sir.
Bolo.
In the before question, we have taken that, no, sir, AN and BN. Why don't we reverse, sir?
So what is the point? You reverse it, no problem.
Then we will reverse means bn by an will come now, sir. 1 by n square case.
Which one? Bn by n. You do it. Bn by n.
Yes, sir. Then it will become 0 now, sir.
Bn by n
Limit,
0. Are you coming with 0? Bn by n.
That means 1 by n square case. If you will take that.
1 by n square case. What is point? What is your point? Limit. What you would like to find? Limit.
Limit n tends to infinity. Bn by n. Where bn is equals to 1 by n square.
Bn is equal to 1 by n square.
Yes, sir.
So 1 by n square into 10 to the 4 plus 3 by n cube minus 2n.
Now it is coming 0, sir.
Sir, their Bn is 1 by n, sir.
Bn is 1 by n square. He is saying that Bn is equal to 1
No,
by
sir.
n square.
But we must take an by bn now, sir, according to the theorem.
Okay, yes, it's correct. This thing is that you have to take always. You have to take this always an by bn. This is a standard form.
Sir, what is a and what is bn? No objection, sir.
We have not specified them.
No,
So here, which is the greatest series?
actually, this an by bn, an always less than equal to bn like this, but not actually. Okay, I will get back to you in the next this point. I remember. Okay.
Sir,
For
in
the
that
last,
here,
sir, in that question, Bn is 1 by n, no, sir.
No, no, no.
For the last question, by the trick,
his
you have
point
given is 1 by n.
his point is if he take 1 by n square, bn is equal to 1 by n square, which is a convergence series. Okay, and he is taking in limit bn by n. He is taking limit bn by n. Then what is the point?
Sir, limit an becomes 0, sir. That it will remain invalid, sir.
yes, sir. If Bn converges and sir, if the limit is 0, sir, then it is invalid, no? If you go up, sir, it is written here. Yes, sir.
So we cannot
yes.
comment on the divergency. We have to take another test.
Yes, sir. If L is equal to 0 and Bn converges, so the test is not valid, sir.
No, test is not valid for the divergency for L coming if L coming 0. Okay.
Yes,
Yes.
sir, but we
Okay.
proved that
Okay.
the divergent test is
Listen.
not valid for divergency,
Yes.
even if we get 0.
Yes. In that case, if you choose bn by an, in that case it will be 1 by L. Okay. So in that case it will be reverse. Understand? You have to take always an by bn. If you take bn by n, in that case this L will be what? 1 by L. And in that case it will be reverse. So 1 by L is equal to 0. That means L is equal to infinity in that case.
Sir,
Understand?
what is
Which one to choose an and which one to choose bn?
And what should be bn?
Bn will be your n is your given function given series, and bn is the unknown series. Here, an is the
Sir,
given
here
series.
how?
This is
Just and
actually
compare
written in the statement. I mean,
Sir, is there any constraint that bn is always greater than an or
No,
something else?
no such constants here. No such constant here in this limit form. In this limit form, no such constant. Only thing is that if you are finding limit, here I am writing like this. Here I am choosing an by bn. If it is coming L, then on this L this restriction is given. If you want to choose bn by n, in that case it will be 1 by L. It will be 1 by L, and in that case you have to put here 1 by L is equal to 0. That means what? L is equal to infinity.
Sir, I have a
Here,
doubt, sir. If they give any
may
two
I
series
make it
Sir,
clear?
but if we reverse it, if we consider 1 by L, then all the rules below that, both A, summation
No,
AN
for
and
the
summation
finite
BN,
case,
they
there is
all
no
will
problem.
reverse.
No, so listen to me. For the finite case, there is no problem. L is finite, then 1 by L also finite, no problem. But if it is coming to 0 and infinity case, in that case, you see an by bn, that statement is given like this, that an by bn if it is L. Statement for bn by n, it will be, the statement will be reverse. Bn by n will be 1 by L. The statement will be reverse in that case.
Sir, there is no condition for B and an AN, no, sir.
No. There is no restriction on this bn and an here in the limit
Then
form.
how can say something is AN and something is BN?
You choose anything. You choose anything an and bn.
Yes, sir.
Sir, AN is the
That
given
1 by
series
n
of the
square is
question.
AN and
An will be given series and bn will be the
BN
chosen one.
will,
sir,
okay,
if
sir,
they
Sir,
the
if
give
we
BN,
two
can
how
series,
choose
will
then
that.
find
compare.
that?
Sir, if we can choose anything, then why we have to take 1 by L? Let it be L, no, sir.
Because the statement is like this. The first series they are taking an and second series is bn.
Sir, if they give
So
two
for
series and ask,
every series,
Okay, you
so for
think
every
about
series, BN will calculate like that only. Numerator is greater term by denominator is greater term. For
what I'm
every
not getting.
series,
And
for
sir,
every
is
series,
there any
BN,
other
how,
method to check
One
whether
by
AN is
any one
convergent?
of you told. Bolo?
so for every series, how will calculate the BN? Like that only. Numerator is greater term by denominator greater term.
I'm not
Like
getting
that
it.
you have took in the previous questions. N cube by n to the power 4.
Huh.
Like that only we'll calculate for all the numericals.
Huh. Is that
That only I'm asking, sir.
that I have told you that this is a one trick you can use.
So this trick is applicable for all questions.
Not for all, or this type of problem. If some 2 to the power n is there, in that case it is not hold. If it is only some particular case, some function of n only, not in 2 to the power form, n form, only n cube, n square, maybe root n.
And then for different question, how will calculate BN?
You have to think about it. Like listen to me. Like if you have here, come down. Here you see n cube by n to the power 4 minus 1. N cube by n to the power 4 minus 1. What will be your bn?
1 by n.
1 by n
1
I
by
can take.
n.
1 by n.
Because
Yes, sir.
why
N to
you
the
are
power
choosing?
4. N to the power 4. N to the power 4.
Hmm?
N to the
Because
power 4 will be Bn.
not a b n to
One
the
by
4. I have told you
one
that
by
you
One by
take
n.
the highest
1 by
degree
n.
in
1 by
numerator
n.
and highest degree in
1 by
denominator.
n.
1 by n.
1 by
n.
Here,
1 by n.
okay. Here, highest degree is 1 by 2.
1 by root n.
Here, highest degree is
1
1.
by
So it is 1
1.
by root n. Like this.
So for problem number 5, sir.
Huh?
For problem number 5, what will be the BN? Problem number 5.
This one. This one.
1 by n to the power 2, 3
Yes.
by 2.
3 by 2. 3 by 2.
3 by
This
2.
will be
1 by
3
root
by
over
2.
n cube.
1 by infinity by 3 by
yes.
2.
by 2.
Okay. I've
So
given
the
you.
last one is tricky one.
Yes. I'm not say anything about this. You
So
do.
we will try that.
You
Please
try
don't
this.
tell
Yes,
us.
sir. We'll try that.
And I think you will not take 5 minutes. Okay, when you write down this question in your paper, you'll not going to take. I know you're not going to take 5 minutes more for solving this problem. Just you need to write your end. You will get. Okay. So keep in your mind, you need to find always some finite limit, because this 0 and infinity case is very much confusing case. You have to get any finite. Okay. Now let me get back to the another test is called D'Alembert's ratio test. I will have to spend very fast. Otherwise, I'll not able to complete this. Okay, D'Alembert's ratio test. Another test. Here, n is a series of positive terms, and if you calculate limit n tends to infinity, n plus 1 by n is equal to L. If you are getting L, I have no restriction on this L, whether it will be 0. See, this L and the previous comparison test L both are different. Here an plus 1 by an. This limit, suppose L, maybe 0, maybe infinity, maybe 1, whatever. The test is like this: if L is less than 1, it is convergent. If L is greater than 1, divergent. For L is equal to 1, no conclusion.
Test fails.
No conclusion. In that case, no conclusion. So D'Alembert's recitals fail for L is equal to 1 value. In that case, you have to choose some other test. Okay. So let's come down to this
Your
example.
voice is breaking continuously, sir. I can't even see the screen.
For the
Network
I
issue.
think that's your network problem. Because I
Network
can
is
see it
it is
clearly.
problem from your end, not Sol's end.
Okay. So now come down to this problem. Test the convergency of this. I was having some mistakes. So like this, 1 by 2, 2 by 2 square, 3 by 2 cube, 4 by 2 to the 4, like this. So what will be your an? Quickly write down. An is equal to what? N by 1, 2, 3, 4. N by 2 to the power n.
2 to the power n.
N by 2 to the power n. What you need to calculate? L is equal to limit n tends to infinity an plus 1 by an. That you need to calculate. So write down quickly what will be your an plus 1
Sir,
here.
it converges. Sir, it converges.
Maybe. I don't know. I'm not going to be going very fast. So L is equal to here limit n tends to infinity. Do it in your own. This is straightforward, very straightforward. 2n plus 1 into the power n by n. Now the limit will be what? 1 by 2. This limit coming 1 by 2 na?
1 by 2, yes.
Yes, sir.
Which is less than 1?
Yes, sir.
1 by
1
2.
by 2, sir.
Which is less than 1? Convergent.
Yes, sir.
Convergent.
So this series is convergent. Actually, what is happening? It n tends to infinity, an plus 1 by an is equal to some finite value L. That means what? It's an plus 1, the next term is always less than some product of some finite value in the previous one. And this L is equal to 1 by 2. So always deteriorating this value. So that's why it is converging. Like this. So come down to the next one. Suppose this series. Quickly write down what will be your an. X to the power n by n plus 1. N. X to the power n by n.
N by n.
Given x is greater or equal to 0, that is given. Okay. So what will be your an plus 1? Xn to the power n plus 1 by n plus 1. So limit n tends to infinity, an plus 1 by an. What will be the limit to it?
X.
The limit is x. So the convergence depends upon this value x.
Divergent.
No.
Sir, divergent.
I cannot say divergent or convergent. This convergence depends upon the value of this x. If x is less than 1, then convergent.
Convergent.
If x is greater than 1, then divergent. For x is equal to 1,
I can't say.
you cannot say the convergency. You cannot say the convergency using D'Alembert's ratio test. Using D'Alembert's ratio test, you cannot say the convergency. Yes or no? This is my point.
Yes, sir. Yes, sir.
But
So
you
how
see,
many tests are there?
Sir, but using other
you see,
theorem,
yes,
it is
yes.
divergent.
Just listen to me. Now,
Yes,
suppose x is equal to 1. So, what will happen to if x is equal to 1? Test fail. I know the test fail. But can we find with our known test? You just have 3 to 4 tests. Okay. With this known test, whether you can comment or not, that you need to check. See, if you put x equal to 1 here in this series, what will be the series?
1 upon
plus 1 by
1
2
upon n
plus
form.
1 by 3. What is this? This is a
P series.
1 by n divergent by n form.
Divergent.
Series.
So now it
Yes, sir,
completes.
divergent.
So now the problem is now completed that using D'Alembert's ratio test, you have this limit. Now for you can say the series is convergent for x less than 1 and divergent for x greater or equal to 1. or in very specifically you can say convergent only for 0 less than equal to x less than 1, and divergent this is for convergency because all the limit is given in the problem itself that x greater equal to 0. So here it is convergent, and for x equal to 1 greater than 1 it is divergent. Now sometimes you may here you see for this particular problem by putting x equal to 1 you are getting this. Okay, no issue. Here just simply you are getting a series, not like this, not like always it will hold. Sometimes it may apply some other test which is not included in your syllabus, but you have to study, I think. So just one series you just note down. I don't know why it is not included in your syllabus, but as it is not included in your syllabus, I'm not saying that it will have to study, but you just study. No, there is nothing else. That rabbis test, not rabbis, rabbis. Okay, so this is rabbis test. What is saying here that this is a series of positive terms, and these tests only do when D'Alembert ratio test fail. Very, you can note down this. These tests only if you do in the case when D'Alembert ratio test fail. First, you have to apply D'Alembert ratio test. If it fails somewhere, then only you have to apply rabbis test. So if D'Alembert ratio test fail, in that case, you have to find this limit n tends to infinity n into an by an plus 1 minus 1. And there is a change here that if L is greater than 1, then convergent. If L is less than 1, then divergent. And for L is equal to 1, again, you have test fail. Okay. So suppose this problem if you take, and you first, I'm not doing this problem here, I'm just telling you, you first write down your an. Okay, use D'Alembert's ratio test. Use D'Alembert's ratio test. Okay, you see, you'll have D'Alembert's ratio test. The limit in that case of D'Alembert's ratio test, limit will be equal tends to 1. So you can say test fail. In that case, you apply Rabbis test, and in that case, you will get either convergency or divergency. You check. Okay, I'm giving this problem like you. So I think you can do. Yes or no? I can.
Yes, sir.
Yes, sir. Yes,
Yes,
You'll
sir.
do.
Yes, sir.
Okay.
We will try.
We'll try.
You'll try.
Convergent,
You'll
sir.
try. You'll try,
Convergent.
and you'll get. I
Sir,
think.
Convergent.
sir,
And
we will
Can
we will
can we
send the
directly
PPT.
use Rab's test?
no, that's my point. Don't use directly Rabbis. Don't use directly Rabbis. First step is that to apply D'Alembert's ratio test, then Rabbis test. If the D'Alembert's ratio test, in only that case you have to use Rabbis test. Otherwise, no.
Sir, what if Rabi's test also fail?
If Rabbis test also fail, if you're able to do with some other test like comparison test or Cauchy's root test, we will discuss Cauchy's root test. If it is possible, then only you can try. Otherwise, if all tests fail, you just write down no conclusion. Bas. It's fine.
Okay, sir.
Okay.
Okay,
Because you
sir.
have only few
Sir.
tests with you.
I will provide these slides today.
I will provide but maybe by evening. Okay.
Okay, sir.
I will provide you.
See, in this slide only the questions are written, na? That
Yes,
practice
yes,
questions.
yes. All questions are written. That's why I have written down here, so that you can.
Okay, sir. Yes.
Okay, no problem.
We will try from there only.
So some problem, I will give you some problem also. And next, let me just 5 minutes. Cauchy's root test. What is that? You see, Cauchy's root test you have to apply when some to the power n thing is there. So that here the limit is what? N to the power 1 by n. That means what? Suppose somewhere if you have some value here, some function of n, and to the power n is there. By seeing this, you can easily choose that it may happen that Cauchy's root test will be preferable. Understand? Not always. I'm not saying this is a trick. I'm saying that as 1 by n power is there. So 1 by n if you do, so you'll get some maybe get some finite value. Okay. So what is the test series? The condition is same as D'Alembert's ratio test. Only for Rabi's test the condition is different, but for Cauchy's root test and D'Alembert's ratio test is all two are same. So L is less than 1 convergent, L is greater than 1 divergent, L is equal to test fail. So now come down to the example. For the first one, what will be your AN? For the first one, you just write down your AN.
But n by 2n plus 1 whole to the power n.
N by 2n plus 1 whole to the power n.
Whole to the power n.
You can see, you can tell me that I can apply D'Alembert's ratio test. I insist you that use D'Alembert ratio test and check whether you are getting any difficulty or not. Whether you are finding, if it is possible to find the limit and you are getting that limit is not equal to 1, then that's fine. It will you can apply D'Alembert's ratio. I'm not telling you that you have to apply Cauchy's root test, but my suggestion is that. But my suggestion is that you see, as to the power n is there, if you do an to the power 1 by n, the limit to find the limit will be easy. So no.
Convergent.
And this limit tends to 1 by 2 as n tends to infinity.
Yes, sir.
And by you can see convergent. Series is convergent. But if you apply D'Alembert's ratio test, you see an plus 1 will be what? N plus 1 by 2n plus 3 to the power n plus 1. So n plus 1 by an will be what? 2n plus 1 by n to the power n. If you're able to find this limit, you can find, no problem. Easily you can find this limit, I think. If you're able to find this limit, okay. Otherwise, D'Alembert's ratio test you can apply. Now come down to this quickly, this example. Can you tell me what will be an is equal to 1 minus 1 by n to the power n square. So here n to the power
So
1
it
by
will
n.
become 1 by e.
1 power infinity.
So 1 by e.
Okay, so the limit will be what? As n tends to infinity,
1 by
this limit
e.
1 by
1
e.
by e.
1 by e.
e.
E inverse, that is 1 by e. Now 1 by e is less than 1 or greater than 1? 1 by e value? E value is
Less than 1.
Less than 1.
less than 1. So this converges.
Less than 1.
Always
Less
less
than
than
1.
one.
So converges.
Converges.
Okay.
n by 2n plus 1 equal to 1 by 3. Sir,
Huh?
n by 2n plus 1 equal to 1 by 3. Na?
Can 1 by 3 cannot? Why?
1
This will be
n
what?
equal to 1.
1 plus 2 plus 1 by n. 1.
Oh, 1 by n. अच्छा.
Okay.
So 3.
Okay.
So the upper part of the slide, can you please show again once?
Huh?
The upper part of the slide, can you please show again once?
This one?
Yes.
Is it okay? Okay. Let me stop here today. I think you will be having class now. So let's stop here today. If you have any query,
No, sir,
you
we
can.
don't have any class.
You don't have any class?
Sir, we don't have any class further.
No, yes, sir. We don't have any class.
So should I continue?
Yes,
Yes,
sir,
sir,
you
we
can.
can.
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Okay, fine. So let me continue. Let me continue and let me finish it. I'll take 15 minutes more. Now, so whatever we have studied till now, all are, you see, positive series, positive terms. There is no negative terms was there. Now there is a series called alternating series. You see just the name alternating. That means alternatively we will be having some negative and positive value. Suppose if a n are always get a1 minus a2 plus a3 minus a4 plus like this, if this type of series is there, alternatingly we have positive and negative values. So this type of series is known as alternating series. So the general term, if I write it as some bn, n is equal to 1 to infinity, so your bn will be equal to minus 1 to the power n minus 1 n. This is the general term. Okay, and for this alternating series we have only one test, that is called Leibniz test. For this alternating series we will be having only one test, that is Leibniz test. What is this Leibniz test? Very simple test, that first of all this n will be a monotonically decreasing sequence.
Increasing.
Monotonically decreasing sequence, first condition. How will check monotonically increasing or decreasing, that I will tell you.
First,
And the,
first differentiate.
no need to differentiate,
Then
I will tell you. And limit n tends to infinity, the necessary condition of series convergence. The limit n tends to infinity, n is equal to 0. If these two conditions satisfy, you can immediately say it is convergent, otherwise divergent. If this is these two now how to check whether the series is monotonically increasing or decreasing is just take the approach. You see, when I say monotonically decreasing, if n plus 1 less than equal to n, yes or no? You see, just
Yes,
you
sir.
the sequence
Yes, sir.
n, that n plus 1 less than equal to n. If this thing happen, then we say it is monotonically decreasing. So for this, what you calculate a n plus 1 minus a n and try to bring it something which will be less than equal to 0. If it is coming, then you can say it is monotonically decreasing sequence. If it is greater than 0, then you will have this series is monotonically increasing. Or you can reverse it, that a n minus a n plus 1, if you find a n minus a n plus 1, this will be minusly greater equal to 0. Okay, that you need to find. Then we say it is monotonically. I will simply take the simple example one, simple one. Always I will do. All of you are able to hear me? Hello?
Yes, sir.
Okay.
Yes,
yes,
sir.
sir.
I thought
Yes,
there is a
sir.
problem. Okay, okay, no problem. No problem.
Sir, please show the previous slide.
Which one? The definition.
Yes, sir. Yes. Okay, sir.
Okay. Now come down to this example. You see what we have now. If you do all this plus sign, then that will be an NP series, P series. But here alternatively we have minus plus like this. Now we test for the convergence of this series. We test for the convergence of this series, this alternating series. So what is your, if you write this like summation n is equal to 1 to infinity minus 1 to the power n an, if you write like this n minus 1, then what will be your an? This is
1 by
actually
1.
the
1 by
nth
1
term.
by n
Okay,
into
let me
minus 1 n plus
let
to
me
the power
let
n.
okay, let me clarify one thing. This is minus 1 to the power n minus 1 an. This is the nth term of this series, not an is the nth term. This is the nth term of this series. Now nth term, if you write like this, there n is equal to 1 by n. Now second condition, always you can check first that this is tends to 0 and n tends to infinity. Second condition of Leibniz test. Now whether it is monotonically decreasing or increasing. So find an minus an plus 1. Calculate 1 by n minus 1 by n plus 1. So that is equal to n into n plus 1, n plus 1 minus n, that is n plus 1 minus n, that is 1. So 1 by n into n plus 1. Which is greater than 0? Yes or no? Which is greater than 0?
Yes, sir. If n is a positive number, then yes, sir.
n is a positive number always, because n start from
Yes,
1 to
sir.
infinity. N is a positive number always. So it is greater than 0. That means it is monotonically decreasing.
Yes, sir.
Decreasing. So
Yes, sir. Yes, sir.
So as monotonically decreasing and an tends to 0, so by Leibniz test you can say this series is convergent. So see the interesting part. If you make it plus sign, this series, particular series, then this is a p series and it is divergent. But when it is you are taking an alternating series, then it is a convergent series. Okay.
Convergent.
Now we will have a very interesting definition.
Sir, if any of these two conditions fail, then it's divergent.
They divergent. Any of these two conditions
Only
fail,
one rule is
Okay.
only one rule. Now write down one definition called no need to write definition absolute convergence. A series n is said to be absolutely convergent. Absolutely convergent means what? The absolute value of each term. Then you will get a new series. You see, summation is n is different from summation mod n. These two series are not same. These two series are not same. We say n series is convergent, absolutely convergent, if mod n is convergent. Okay. So n series is said to be absolutely convergent if mod n series is convergent. And another is definition is that conditionally convergent. Conditionally convergent means if n is n said to be conditionally convergent if the absolute series is divergent, if the absolute series is divergent but n is convergent. It sometimes may happen that a series is convergent but not absolutely convergent. It is convergent but not absolutely convergent. Then absolutely convergent, that is a model n is divergent. In that case, it is say conditionally convergent. And you can note down one thing that absolutely convergency always imply convergency. Absolute convergency is always imply convergency. But the reverse one does not hold. That convergency does not always imply absolute convergency. Can you give one counter example? You see just the last one. You see, if you take this series,
P series.
1 p series 1 minus 1 by 2
Sir,
plus
you can
not
take P series.
this one. You see, this series is what? Conditionally convergent or absolutely convergent? This is your
Conditionally convergent.
conditionally convergent. Why?
Conditionally convergent.
If you take the absolute
Conditionally
value,
convergent.
if you take the absolute value, that will be a
Conditionally
p series.
convergent.
So this is summation. If I take, then summation of mod n, that series will be equal to 1 plus 1 by 2 plus 1 by 3 plus like this. And this is actually a p series with p value is equal to 1.
That is
With p value is equal to 1, so it is divergent. So it is the series n
yes,
is
sir.
this series is convergent but not absolutely convergent. So it is conditionally convergent. And again, if I consider another series like summation n is equal to 1 minus 1 by 2 square plus 1 by 3 square minus 1 by 4 square plus like this. If I consider this series is what? Absolutely convergent or conditionally convergent?
Conditional.
Conditionally.
Absolutely convergent.
Conditional.
It is.
Conditionally, sir.
Absolutely convergence.
Absolutely convergent. Absolutely
Absolutely
convergent. You
convergence.
see, this series is,
Convergent.
if you take the absolute value,
P is equal to 2.
if you take the absolute value, that is p series with p value is equal to t, which is greater than 1. Now, so that my point is that sometimes either by Leibniz test you can say, or using this property you can say. Suppose if you use this test here, you can get the convergence. But without using Leibniz test, by using this property, you can say this is also convergent, because absolutely convergency always implies convergency. So as this series is absolutely convergent, so you can say this series also convergent. Understand? Absolutely
Sir,
convergent.
can you please explain the last one again?
Okay. Absolute convergency always implies convergency. That means if you find that a series is absolutely convergent, then immediately you can say series is convergent. Suppose you are asked to test that this summation an is equal to 1 minus 1 by 2 square plus 1 by 3 square minus 1 by 4 square plus dot dot dot. Is it a convergent series or not? If you are asked to find, what you will do? You have to test by Leibniz test. In that case, you have to take the limit n tends to infinity 1 by n square is equal to 0 coming. Then you need to calculate n minus an plus 1 and check whether it is coming greater than 0 or less than 0 like this. You have to do so many calculation. Without using this Leibniz test, you just check whether the absolute series is convergent or not. You see, if you take the absolute series of this one, what will be this summation mod n? That will be what? 1 plus 1 by 2 square plus 1 by 3 square plus like this, which is a p series, and you know it is convergent. So without doing lot of calculation, just using this property, you can say as it is absolutely convergent, so that means this series is convergent. No need to use Leibniz test here. Okay. Now,
Sir, please keep it till here, sir. We are having some other work.
what? Hello. Okay. The last problem we will do here.
Keep it till here, sir. We are having some another work, sir.
Just 5 minutes. I will complete by 5 minutes. I've told you I will take 15 minutes and just complete. Let me complete. Otherwise, just one problem I have to carry out.
Okay, sir.
Okay. Suppose an is equal to. Okay, let's stop here. I will do this problem next day and complete. Okay. Then we stop here.
No, sir. Continue, sir.
Thank you, sir.
Sir, there is only one problem left. You do it, sir.
You
Okay.
can.
You continue, sir. Sir, do not need to stop, sir.
So let me do it.
Yes, sir. You can
Cos
complete it.
n pi n square plus 1. Test the absolute convergency. So what we will do? This is whether this series is an alternating series or not. First tell me. Cos n pi is equal to what? Cos n pi value minus 1 to the power.
So 1 or minus 1?
1 or minus 1.
minus 1.
So it is an
sir,
alternating
minus.
series. So if you take mod, this is cos n pi by n square plus 1, which is less than equal to 1 by n square plus 1. Yes or no? Can I write?
Yes, sir.
Cos n pi plus this one.
Yes,
And
sir.
1 by n square plus 1. Can I write this one is less than equal to 1 by n square?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir, definitely.
Suppose this is bn. So
Yes,
we
sir. It is
have
convergent. It is
we have
convergent.
mod an less than equal to some bn. Mod an. So this mod an less than equal to bn by using comparison test, as bn is a p series which is convergent. So this mod n is also convergent. Mod n is also
Mod n.
convergent. So as mod n is
Yes.
convergent, that means what? N series is absolutely convergent. So n is absolutely convergent. And moreover, you can say it is convergent. Clear?
Yes, sir. Yes.
Yes, sir.
Okay. So that's much we have, and I am giving
So
you
can you repeat it again?
n is equal to cos n pi by n square plus 1. You have to test the convergency of this series. You have to test the convergency of this series. I am writing mod n will be what? Mod cos n pi by n square plus 1. And you know cos n pi, the value will be mod if you take. Value will be either 1 or 1 minus 1. Value will be 1 or minus 1 for cos n pi. So if you take mod, it will be always 1. So I can write this is less than equal to 1 by n square plus 1. Okay.
Yes,
so,
sir. Yes, sir.
So 1 by n square plus 1 less than equal to 1 by n square, which is a p series. By comparison test, you can say n is a convergent series. So mod an is convergent. So mod an convergence means it is absolutely convergent, and absolute convergence means it is convergent. Okay.
Convergent.
And
Okay, sir.
I am giving some problem here.